as you have graphed lines, you've noticed that some of them have some relationship, whether they head in the same exact direction or they cross at some point. We're going to talk about two relationships between lines. One of them is to have parallel lines, and the other one that we're going to talk about is perpendicular. To start off, we'll look at two examples. Y equals 3/8x plus 4, and the other one, y equals 3/8x plus 5. Now if we put both of these on the graph, rough sketch here, this guy has an intercept 0, 4 and has slope 3/8, which means from that point we go 1, 2, 3, 1, 2, 3, 4, 5, 5, 6, 7, 8. So it looks like this, or, you know, straight approximation to that. Now the other guy, y equals 3/8x plus 5, he's at 0, 5, so he's already up at this point right now. That's one point on the line, and he has a slope of 3/8 as well. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. So he went the exact same distance up and the same distance over, and with that same crookedness that was there before, you see that these two lines actually never cross. This is what we call parallel, these two lines, and that is seen by lines that have the same slope. These guys are then parallel. Now we look at the other one. Well, we could look at a couple more here. If I have 5x minus 7y equals 9, 5x minus 7y equals 39, these two lines are going to be parallel. They'll never cross because this is going to have a slope 5/7, which will establish its steepness, its direction, the direction it's headed. And this guy is going to have slope of 5/7, so these two lines are parallel. Now let's look at the other guy, perpendicular. Let's take a line y equals 2/7 x plus 1. If we put him on the graph here, we're at 0, 1, and then we go 1, 2, 1, 2, 3, 4, 5, 6, 7. So we went up 2 over 7 to this point right here. Okay, it's about as good as I can do. So there's the slope of 2/7. Now the question comes, how do we get something to come in at 90 degrees to that? What does it look like? What is its slope? How is that a relationship to this slope of 2/7? Well, I want you to imagine that you took a hold of this line, and we could fix it anywhere here. We're going to fix it right there though. And you twisted it 90 degrees in this direction. Just grabbed a hold right there, grabbed a hold right down here, and just turned it around this point until it was headed down about like this. Now you'll notice what will happen to this 2 and this 7. And now here's your 2 and here's your 7. So if you were starting at this point to get to that point, this slope is now, notice where it was positive, kind of shallow, headed up. This is now steep going down, and it's a negative 7/2. It still has a 2 and a 7 in the ratio, but the 7, which used to be horizontal, is now vertical, and the 2, which used to be horizontal, vertical, is now horizontal. So we have a slope of negative 7/2. So this guy and that guy, that's how you get perpendicular. Another couple of examples. If you have 2x plus 3y equals 8 and 3x minus 2y equals 7, this slope is going to be negative 2/3, and this slope is going to be a positive 3/2. If they are negative reciprocals, let's write that down, negative reciprocals, then that is what makes perpendicular.